Hello,
Okay, so
everybody. Yeah, I
can
am
can I share the
here.
screen?
Yes, please try sharing the screen. I'll do a quick intro and then hand it over to you.
Yeah.
So, hi, everyone, and welcome to the Paper Club, our one before last edition for spring. Theme has been agents, and so we're here as part of the community. My name is Elena. I'm the executive director of the Human Feedback Foundation. We are a nonprofit advocating for human-centered AI. We sit under Linux Foundation AI and Data, and we are partnered with AI Thinkers Global to produce the Paper Club. We also run Toronto chapter of AI Thinkers, which is really growing really well. We have about 2,800 AIML builders and entrepreneurs in the network, which is amazing. And so today we are taking you all through the agent company paper. And so I want to welcome Yufan. And how do I pronounce Boxuan, your name? Just so I don't screw it up. I'm so sorry.
That's right. That's right. Yeah. Thank you.
Boxuan? Okay, amazing. So we have two amazing researchers with us today, and they'll take us through their work, and then we'll take questions. Please add your questions to the chat, and I will pick them in and get them into the discussion in the second half of the presentation. So over to you, Boxuan and Yufan. If you can introduce yourself and just dive into it, would be great. Thank you.
Okay, thanks for your introduction. So, yeah, today we will share our paper and project, the agent company. And this work is did by me and Boxuan and Frank, and also advised by Professor Graham Newbig. And currently, I'm a senior software in the ByteDance doing some LM work, and Bojan is at Microsoft doing some also a senior software engineer. And but this work is just our personal side project, personal research project. It's not related to our employee. So this is a clarification. And yeah, let's begin. So we built the agent company, and it's a benchmark to benchmarking the LLM agents on consequentials real world task. And I'm not sure whether you guys have heard about the Web Arena. It's another benchmark, and I would say that the agent company is a follow-up work of the previous benchmark. So the Web Arena, this benchmark are done by Frank Shuyan and also advised by Professor Graham. And that benchmark is focused more on uh, people's daily life's work, such as if we want to go out, we need to find a path in the map application to find a way from our home to school to your company. And also sometimes we want to shop online. And the web arena creates lots of daily life's work on that benchmark. And that benchmark got very popular. And so the professor Graham think, wow, we already have a benchmark to benchmarking the agent's performance on people's daily life. Then how about we build another benchmark on real world task in the company? Then we have the agent company, this benchmark. Yeah. Uh, I will share the first half of the slides, and the portion will take the following work after I share my share finished. Yeah. And also we have a fantastic demo in the end. Okay. So let's see. Okay. We do various digital tasks every day. We interact with computer every day, basically. And many aspects of our work can be done entirely with access to a computer and internet. We perform various digital tasks like admin, data science, software, human recruiter, or resource or recruiter or project manager, and the finance. We have different types in even in a startup, a small company. And the human need to interact, communicate with our coworkers every day. In the company, you need to interact with your CTO, with the CEO, with the recruiter, with the engineer people, and we will use a browser to see some doc. We need to use browser to chat with our colleagues, and also for the software or data science, we need to interact with the computer. We need to use a terminal to do some programming work. Yeah. Then how about agent? At the same time, the agent supported by the LLM also has demonstrated potential in some web navigation or desk manipulation tasks. But how about their performance at this area, helping to accelerate or even autonomously perform our work-related tasks? So yeah, as you say, how about we put the agent in the same place, and what will they do in the end? Then we build the agent company. The agent company can, I would not say totally perfect benchmark this scenario, but would help at least provide a good way to benchmark it. So we will give the agent several tasks as human, as you say at here. We got the admin. If we let the agent do admin task, it will arrange the meeting room. If we let them do the data science task, we will require them to analyze some spreadsheet. Let's say this part. Actually, we will call this part as an environment. So in this environment, we will we build this for agents. And for any agent, they just need to interact with this environment, and we will give them a score. And I would say this environment includes many things. So firstly, they need to we host several websites. So here are 4 websites. The first is the Rocket Chat. The Rocket Chat is like chat tools, online chat tools like Slack or Teams, any chat tools in your daily work. And Owen Cloud is like a Google Drive or alternative. It can storage many files, the doc file, the Excel file, the video, the audio, any file you want the people to check, you can place it on here for file sharing. And the third one would be the GitLab. It's very famous. It's just a code host website, and many software engineers will need it in their daily work. The final one is Plan. Plan, just like a Jira, is a program management work. And yeah, it's a project management website, and we will create account for each people in the plan, and each people will have their own group and their own program, and there will be some progress about the progress of their program, and we will create task on it. Let the agent do. And let's say about here. So we make a fake company. That means we create around 50 fake people in the background. For these 50 people, we assign different roles for them. Some are, we have one CEO, we have one CTO, and we have some software engineer, some recruiter, some project manager, and different types of roles. And these fake people also have their name, their background, their age, and they're from different race, different national around the world. So we try to make it as real as possible. The future is awesome. Oh, how soon we will have the entire company run by agents?
Oh,
We can.
don't worry sorry. Don't worry about answering questions. We can do that in the second half. This
Okay.
is just a part of the discussion. Yeah.
Okay, sure,
Sorry.
sure. Okay, I will close my ch chat. Okay. Then after we make this fake background, we also provide the terminal environment. Let's say if the software engineer want to write some code and execute it, we'll place it over here. And this terminal can also access the internet. That means it's just like your work environment. And if you need to install some Python package, it's fine. You just use the pipe install. And for some human resource work, there are some, we will give them resume screening task. That means we will let the agent do, assume they are a human resource, and they need to browse maybe hundreds of the resume on their own cloud. And firstly, they need to figure out how to download this screen and check their content and filter the contents by the requirement and give the best candidate out. Also the PM, maybe there are some team sprint planning work, then they need to go to the plan and learn how to use it and communicate with other engineer about their sprint. And for the finance work, maybe we will upload some reimbursed travel bills. Also put this image in OnCloud or send on the Rocket chat, and let the agent to figure out whether these reimbursement bills are qualified. Yeah, I think these are some real world tasks, and all of these tasks are created by the expertise in each field. We find many people to create these tasks. For software, I would say we find about 20 people some are computer science students, some from the tech company, from the junior software engineer to senior to software engineer manager. They create their daily work at here. And also data science is the same. And also we find two human resource people from the CMU computer science department to help us to create this task. Yeah. And for this size, I would say this is some consideration that hold in our mind when we create a task. So firstly, we want to coverage the multiple work-related tasks because for current benchmark, like the mini Vol++, it's actually not related to real-world task. And for Sweetbench is a very famous benchmark, but it's mainly focused on the coding area. And as we all know, only software engineer cannot support a company. We need different types of the job, like as I mentioned before. At here, we have different roles actually. And the agent company the agent company have different types of work, and also this work are mainly happen in real companies. And the secondly is the requirement for the interaction. I think this is a very difficult work for agents because most of the work pipeline just like you give an instruction to agent and the agent will blah blah do some work, interact with the environment and give you your result. But for the agent company, I would say over half of the work requires the agent to talk with the colleagues. And I would say this is this part. And this colleagues actually is backed by other LLM. It's also fake people. Also, you can call it another agent, but they should be a more powerful agent and their task is relatively easy. So we can control the quality of their reply. Such as if you want the agent to study some things And in other benchmark, they will directly give the agent the file link or the URL of the document. But in our benchmark, we will let the agent ask for his mentor, his colleagues. Assume this, we will tell the agent, you are an intern, you need to ask for your colleagues or mentor for help to learn something. And in the mentor or the colleagues part, we will let that agent to tell the file URL to that agent if they asked. And it's a relatively easy work, but for the agent we want to benchmark, it will be complicated because they need to do some chat in the Rocket Chat's website, and also the reply may have some delay designed by us. Because in real world, it's very normal that you ask some question but no one reply you. Then it will require you to ask for others or send it to some public channel or just wait. It's more complicated, I would say. And back to here, we have some long horizon task with checkpoint. I will introduce it in the later slides. And there are some environment interface. Yeah, as I said, we have different tools. We can do browser, we can do command line, we can execute the Python program, we can chat with others, with colleagues, and the self-hosted and the reproducible. Yes, because all of these environments are did in the Docker. If someone knows the Docker, I would say the Docker is very easy to distribute to others, and it's very easy to start, easy to reset. And the environment is easy to set, and that will guarantee the safe execution. The also easy for people to extend our benchmark. I would say many of the people will think the agent company provide a good framework and they will add their own task on it. Yep. And yeah, here is the environment setup. We got the sandbox Docker environment, and the agent will do observation and will get observation and will execute their action. And in the local space, we will have the Bash, we will have the Python, and it can support more programmatic scenarios. You can install Python, C++ or Java or any language you want in this environment, or you can just let the agent install it by themselves. And also, we can interact via, we can go to the internet via the web browser, and we host for website, for plan for PM work, and GitLab for some software engineer work, and OwnCloud is for some general work. It's a file drive, Google Drive alternative, and Rocket Chat is also for more all of the task. And also we got simulated colleagues with different knowledge, background, context, and let the agent to communicate with them. Yeah, and all of these websites are reproducible and resetable. And it's already injected with some mock data from our previous setting. Okay, so here is the task structure. We can say here is a detailed example. We got different domain. So here is different domain, the PM data science software. And this is the details of a task. It will tell the agent what they need to do. So for this example, analyze the agent company's performance and create a summary in plan. So firstly, they need to access the plan. We will give them an URL, and they need to figure it out how to do the browser, how to navigate to this place. And then they need to collect the metrics. There are some metrics we provided, but to be honest, I also don't know where this metric is. They need to figure it out on the plan itself. And also based on the collected information, they need to create a summary and share it with Rocket Chat. It's just the online chat tools. It's also another URL. in a public channel. I think it's a very, very easy and general daily work in humans' work life. And the agent got this instruction and they will just do the work. And when they finished, they will tell us, and we will launch the evaluation program. And for the evaluation program, we actually have different checkpoints. So like here, for example, if we have 4 checkpoints, we will split the check. Actually, there are 4 sub checkpoints. And if they finished 1 sub checkpoint, we give them 1 score. And if they didn't got it, we got 0 score. And sometimes in some situation, if they finish the final checkpoint, that means the tasks are done. But then we will directly give them 4 score rather and ignore whether they finish the previous actions, because the Professor Graham think the way that agent work are different like humans work. So we can not assume the agent will do work just like our humans. I will take one example is if you let people to create a dog and write something, most people will, I would say 90% of the people will open an UI place and write dog and then save it or download it. But for agent, it's totally different. The agent may use the Python code to create a file and write something in it, or use a batch file to do it. It is much more easy for agent to use the code to operate something rather than use an AI, rather than use some GUI things. But the human is totally different. So let's back to this example. We have 3 checkpoints. We will check firstly if the plan was accessed, because we told them to access this website and find the information. And secondly, we will check whether the information they collected is correct. And thirdly, we will check whether they have sent the message in the rocket check and whether their content is totally correct. And all of these checkpoints are our manually created script done by our coworkers. And I would say it's very time consuming. And we also let me and Boxuan also checked it twice and make sure the evaluation script is totally correct. Yeah. And for each checkpoint, we will check the different dimension, I would say. The first is check whether this action is whether complete. And the second is check whether data is accurate. And thirdly, it will check whether they do the multi-agent communication things. Yeah. And for task creation, we create this task from the ONET online. I remember it's a United States government website, and it lists many different types of roles and it works. And we select some roles from here and create our fake company. And we try to create diverse tasks for each job. And for each task creation, it's very time consuming. We have around 20 people in this paper's author, and most of them are due the task creation. And it costs around 3,000 human hours, and all of our progress are shown or recorded in our GitLab project. We create them issue, and some people will pick it and create a PR for the task. And all of the details, review process, and code are listed over there. If you are interested, you can directly check our website. Yeah, and I think I will handle the left work to Boxuan. Boxuan, can you share your screen? Oh, you need to unmute yourself, Boxuan.
Yeah, sorry. Am I audible now?
Yeah, you are good.
Yeah. Thanks, Yufan, for the introduction to the benchmark. I see a lot of people are interested in our experimental setup. I'll talk about them. First of all, this is not a 100% complete table comparing to other benchmarks, but we do we did a sophisticated related work studies. And as you can see from the table, most benchmarks we compare to are browsing tasks because they are browsing oriented benchmarks because they are most close to our work. And but most of them are not diverse. They're not real world work. They don't require interaction with coworkers, which in our settings are other agents. And none of these benchmarks have a long horizon. Some tasks are easy for agent when it's short, but if you make it really long, like it becomes much harder for agents. Like it's relatively easy for a specialized agent to screen one resume, but if you ask it to do the same thing for 200 resumes, it becomes much harder. So that's what our benchmark focuses on. We create 175, most of which 175 tasks, most of which are long horizon tasks, and we have a self-hosted environment. We have multiple task categories, not only office or coding, but some other categories as well. And we believe we try our best to have it represent a relatively diverse real-world workloads. And the way we do our experiments is we at the benchmark, we only provide an environment, and technically you can use any agent to do the experiments. And we selected two popular open source agent frameworks or two popular agents to do the baseline experiments. We used one is called OpenHands and the other one is called OWL. OpenHands, formerly known as OpenDevon, was initially a fork of the famous project Devon, and OWL is a open source fork of another popular agent, closed source agent called Manus. So we selected two agent frameworks to show that it's relatively easy. It's not too hard to have different agents integrated into this benchmark. So here the graph you see is a demonstration of OpenHands. As an agent, it essentially is LLM plus an execution environment. So it has a browser backed by a Playwright. It has an interactive Python Jupyter server, and it has access to a bash so that it can run arbitrary commands. And that's all you need to build an agent, at least believed by the OpenHands community. And we tested multiple LLM backbones using OpenHands. We only selected GPT to do the experiments for OWL because OWL has some limitations on models. This is an experiment workflow, how an experiment workflow roughly looks like. Agent gets an input task. It's written in natural language in English, written by by our task creators. It describes the complete scope of a task, and that's all the agent has. And based on that task, it may need to visit one or more websites. It may or may not need to write code in the command line, and it may or may need to talk to its coworkers. And at the end, after it finishes the task or fails, we have evaluation testing harness to evaluate how many checkpoints it passes and whether the agent has successfully resolved the task. So we really try to make it pluggable. So task environment initialization is done by the benchmark framework. And if you want to test another agent, you just need to plug it into the environment, let the agent read that input task and do the execution. And finally, the evaluation harness is done by our benchmark infrastructure. So this is the performance we get. These are all using OpenHands framework. So you may wonder why we only try 2 agents. That's because although there are a lot of open source agents on the market, we do need an agent that can not only write code, but also browse, do interactive browsing on the internet. Not only read from web pages, it also needs to click, drag and drop, do texting, or so those interactive or even uploading and downloading files. Those interactive capability is not offered by a lot of open source agents. So we selected OpenHands and OWL, and it's a little bit unfortunate that OWL doesn't perform very well. So hereby we only show the performance by OpenHands backed by different LLMs. So since we're using the same agent framework, it's kind of apple-to-apple comparison between, well, kind of relatively apple-to-apple comparison between models. And we saw Gemini 2.5 Pro and Cloud 3.7 Sonnet are clear winners. Recently, some other researchers from Carnegie Mellon University have released a paper on a new agent modified from OpenHands, and they also used Cloud 4.0 Sonnet to do the experiments, and they got SOTA results. They got 33% of task completion ratio, relatively higher than the top we got, but still not very satisfying to get 33% resolved out of 100%. This is a table of our experiment results. We see Gemini 2.5 Pro has highest success rate. Similar, Cloud 3.7 Sonnet has similar performance, but both of them are very costly. And it takes them on average 27 steps to finish tasks. And it's interesting that Gemini 2.0 Flash is performing relatively well, although not one of the best, but it finishes 11.4% of the tasks, and at a really low cost, so it's pretty cost efficient. We evaluated a few open source models. We did this experiment at the end of last year, so back then Llama 3.145B was the strongest open model. Now it might be DeepSeek or Llama 4. But we didn't evaluate. And Yufan introduced that we provided four fully self-hosted environments. They are GitLab, Plan, RocketChat, and OnCloud. And we also have a relatively wide spectrum of tasks. So we categorize them into 6 major categories: software engineer, project management, data science, administration, HR, and finance. And this is the different models' performance on these platforms and different task categories. OnCloud, among the 4 websites, has the most complicated UIs, especially when you need to edit a file, a doc, or a deck of slides online. So there's really a lot of buttons on the website, and it often confuses agents. And so you can see actually all models perform relatively worse on this category than the 3 others. And we consider as task creators, we consider software engineering tasks as human hard. And actually, some of them are really hard. For example, some task is real world Carnegie Mellon University's project for graduate students. And we verified there's no leaked answer on the internet. It usually takes a Carnegie Mellon graduate student a few hours, if not a few days, to solve that project. But Gemini Pro 2.5 was able to solve it in 10 minutes. And interestingly, data scientists, admin, and finance tasks, despite relatively easy because they're basic work, they're not super complicated finance tasks. They're kind of hard for agents. And hereby, I wanted to introduce a few common agent failure we observed during the experiments. The first common failure is incompetence in browsing. So we observed that it's still very challenging for agents to browse interactively in the modern websites. For example, this is a screenshot of how OnCloud UI looks like. Every time you log into OnCloud, it has this pop-up window asking you whether you want to download their apps. And agents consistently have problem closing this pop-up. On one hand, this website is not designed to be agent-friendly. It doesn't have enough rich meta tags on every button. On the other hand, this pop-up button is very small. It's not very evident to agents. So throughout our experiments, we see a lot of agents struggling just to close this pop-up, and let alone follow up more complicated tasks navigating through this complicated UI. And we see in some cases, lack of social skills leads to agent failure. Sometimes agents stick to the original input, the first task intent. If the goal of the task changes in the middle, for example, sometimes agents are asked by their coworkers to do something else, and sometimes the agent would refuse because it thinks, sometimes it doesn't refuse, but it ignores what its coworker says because it thinks it only needs to finish the initial task. And interestingly, we see some examples where agents try to avoid work via fake shortcuts. For example, in one task, it needs to find a target coworker and talk to that coworker, but due to the complexity of the UI, it fails to find that coworker. And instead, it decides to rename itself to the target person and talk to itself and pretends that it finishes the task. Of course, it doesn't. Our evaluation harness captures this problem and doesn't give it full marks. And we hoped our research would be useful for future more sophisticated benchmarks, and we hope it can help answer whether agents can do real-world human jobs. And our research finds out that agents can solve some tasks successfully, and some are surprisingly cost-efficient. But the overall success ratio is still very low, and we don't think agents today can replace human jobs fully, but they can be helpful to assist human work from day to day, for sure. And Elena, it's up to you whether we want to use 18 minutes for Q&A, or I can use 5 minutes to do a quick demo.
What do people want? I'm just gonna do a quick demo, like
All right,
Q&A.
yeah, sure. I wanted to say, like, all the results are available on GitHub, so you can also navigate to GitHub and see what agents do, what each agent does in each task. This is one example of how a task looks like. Just a reminder, we have 175 tasks, and I personally consider this as one of the easiest tasks, but none of the agents were able to solve this task fully. So let's read the task input together. This is all the information provided to the agent. You are a quality engineer. Today, you happen to find a severe security vulnerability in the code base that could lead to our customers' confidential data leakage. you need to escalate this issue to the responsible developer as soon as possible. Go to this website, and this is a link to the Rocket Chat self-hosted website. Find John Wei and told them about this emergency. If they don't respond after 10 minutes, escalate this matter to our CTO, Sarah Johnson. Sarah may not reply, but you can consider work done after you notify Sarah. And the evaluation harness is designed to check first whether the agent actually tells John Wei about this emergency. Second, whether the agent, I should mention that in this task settings, we intentionally make John Wei not to respond to simulate a common real-world setting where your coworker may not respond to you as soon as possible. It's very common for them to be away from keyboard, or they may not have time to respond in a timely manner. So John Wei is designed to not respond at all. And so the second checkpoint we do is to check whether agent actually escalate this to the CTO, Sarah Johnson. We check the conversation history between the agent and Sarah on the Rocket Chat platform. And the third and the final checkpoint is we verify the timing between the two conversations. We verify if the agent only notifies Sarah after 10 minutes, because that's what's requested by the task. And we add this requirement to simulate also a very common working scenario. If you talk to your coworker, you don't expect them to answer in a second. And it's very common for them to take a few minutes to understand what's going on and respond. So we say that you should only escalate this issue after 10 minutes if you don't get any help from John Wei. And the source code link is available here. We'll post the slides later. So OpenHands has an integrated browser environment. And this task, unlike some other tasks, does not require any coding. So everything agent does is on the browser. So I'll just show you the screenshots we take from every agent step that it did in this task. First, it logged into Rocket Chat. This is how Rocket Chat looks like. It's an alternative. It's an open source Slack. And it did something stupid that we cannot see, but you can see the two screenshots are the same, meaning that it didn't do anything meaningful. Probably it clicked on some button that's not clickable. Okay, and then in the third step, it navigates to the channel page because it needs to find the target user, and then it navigates to the users tab. So here's something interesting. Although you don't see the target John Wei on this website, as a human being, you will naturally search its name here in the search bar and then click on its name. But here, I believe what happened is Rocket Chat actually displays all the coworkers on the same page. It just, the other coworkers are just hidden. So even though this web page only shows 8 coworkers, the agent was actually able to see the invisible coworker and click on that link. And in the next step, it already finds the target coworker, John Wei. And the message it sends to John Wei seems reasonable. I've discovered a security vulnerability in our code base. This requires immediate attention. Please discuss. So let's look at the time. 4:08 a.m. And of course, John Wei did not respond as designed. And then agent decides to escalate and finds the CTO, Sarah Johnson, and escalate the issue. It says, I notified John Wei about this issue 10 minutes ago, but I haven't received a response. So it decides to escalate to Sarah Johnson and calls the task as finished. But interestingly, if you look at the timestamp, it's only 4:09. I look at the agent's thought in the log, and it says, let's just assume 10 minutes has passed. So instead of using terminal or browser to check the current time, it decides to ignore the timing requirements and just assumes time has passed. And consequentially, oh, and it's not just one LLM that makes this mistake. Actually, no LLM backing OpenHands was able to finish this task. All right, this is relatively one of the simplest tasks in our 175 tasks. If you're interested, feel free to check out our repo. It has all the tasks. All right, I guess we can leave the floor for Q&A.
Amazing. Thank you so much. And thanks to Joe, by the way, who joined as this session was underway. So Joe, if you have any questions, please feel free to jump in. I will poach questions from the chat. And yeah, really impressive demo. Honestly, special thank you for the demo. We're going to ask all our future speakers now for a demo. Question from Robert Franklin. Are there any standard orgs forming on creating standards for AI-friendly websites? Because it seems like so much of that UI is just meant for human navigation. And so they run into, dead ends.
Yeah,
where
that's a
they're
great question.
missing.
That's a great question. And I realized I didn't mention that how OpenHands actually does the browsing. There are two primary ways by agents to browse the internet. Well, I should say there are two popular ways among all the agents. One is text-based browsing, which is what OpenHands does. So the way it does text browsing is, I don't know if you guys know, modern browsers have this accessibility feature called accessibility tree. It's designed for blind people to read the websites. It automatically converts websites into a text tree, and it contains the text information and tags to describe images, and also whether a button is clickable or not. And OpenHands uses this input to read the website. And in the OnCloud example, that pop-up button doesn't have correct meta tags to describe its buttons, and it makes the agent very confused. And in fact, in reality, if you are a blind person using this accessibility feature, you would also get confused because you have no way to close that pop-up just by having the browser reading the accessibility tree. So I think it's modern web designers should really consider should not only consider how your website looks like visually to human beings, but also whether you really follow the HTML standards. For example, the accessibility tree should have been a primary concern of web developers because this is part of the HTML standard. But the reality is, not every website developer cares about this. A lot of people only care about how they visually look like. And this is not only bad for some agents, but also bad for blind people who needs these accessibility features. So that's interesting. And there are also some ongoing projects, commercial and research projects on how we should design modern interfaces that are more friendly to agents. For example, how should we structure our data? How should we structure our representation on websites to make it more friendly to agents to read? I think that's a very promising direction. And I hope that helps. Yeah.
Yeah. So I'll invite a few of you to ask some of your questions in person. If Bartik, if you want to ask yours next, please feel free to do so. I'm asking you to unmute.
Yes, thank you. Yeah, no, it's just what I posted up there. Really, the TLDR of it is, I think these capabilities are amazing. And by the way, I've been following your paper since, a few months back when you guys released it. It's great work. But can you comment a little bit about, kind of providing observability for, the agents and the teams and the processes that we deploy, right? Because when we talk to customers who want to deploy these things, for them, more than the abilities of the agents, it's more being able to see what the agents are doing and how they are doing on the tasks and so on and so forth, right? Is that something that you guys have thought about at all? Because that's what really makes it real for them, right? It's great to show demos and so on, but they want to see how it does on their use case and on their problems and so on and so forth. So any thoughts on that?
I'll talk a little bit, and maybe if I can chime in if you have any thoughts. This is interesting, and a lot of people in the open hands community have expressed interest in how we can make LLM observability better. And what I have observed in what happens in open hands community is they're really trying to make what agent is doing accessible to human users. So if you go to the open hands repository, they actually have agents doing a lot of software engineering tasks independently. And in their GitHub issue or GitHub PR, if you add their agent to do stuff, it will post a link, and the link is live. You click on that link, it opens a nice web UI, and it actually shows what the agent is doing right now. If the agent is writing code, you can see the online editor. If the agent is browsing the web, you can see its browsing history live, and you can also see the agent's thoughts on a side panel, again live. So I think this is at least what people want. They want to know what the agent is doing before it does any damage or spends too much money. So they want a way to see what the agent is doing right now. They want observability. They probably also want the ability to terminate what the agent is doing, or interrupts and steers what the agent is doing. But that being said, I think there's still a lot that community can improve on how we can make observability better. For example, when it comes to security issues, when it needs to prompt username and password, how can agent designers do better to detect any security-related concerns and, for example, pauses the task and let human intervene? And I see different agents have different designs. For example, from my personal observation, I see that GitHub Copilot agent is very cautious about what it runs in the terminal. Every time before it runs anything on the terminal, it will stop and ask for humans' agreement. On the other hand, OpenHands usually doesn't ask for human consent. It just runs commands. And to prevent security issues, they have a plugin that is optional, and it can detect any potential security vulnerable task actions before the agent actually does it. I think it's still a very open area for researchers and the industry.
Yeah, thank you. I think that tracks with our experience. Thank you.
Amazing. Joe, do you want to ask about the costs?
Sure, yeah. First of all, thanks for joining us today. This is great. This is one of the first studies I've seen that actually started to break down and talk about cost of agents as well, not just the quality. And so I was really curious about that. Just double clicking onto that, like one's kind of detailed question, one's more big picture. The detailed question is like, what are the cost drivers? I think when we talk about agents, we're always focused on the inference costs of tokens, but there are now other costs when you think about these kind of agents where you're doing computer use or browser use, or even just, running in production. You might have to have a cloud hosted browser infrastructure thing like browser base, right? These are added costs that are significant. So I'm curious how you looked at those costs. And then if you get into like streaming a user interface just to get better, more data, you're talking about the cost of video in real time. So I'm curious about those cost drivers. And then second was, when I see a task, completed and a total cost, I immediately think, well, what was the human equivalent cost? Where's the frontier there? And are you looking at that?
Thanks for the question. Yufan, do you want to answer?
Yeah, sure. So for the costs, I would say for most coding tasks, the cost will be a little bit higher because you always want to input all of the coding files into the agents. Then it makes their contexts are very long and the output token is very long. And also the browsing cost is more higher than the coding work because the website, the HTML is much more longer than just the files. Or if you want to use the GUI solution, the GUI actually are much higher than the text-based solution. And I would say, at least now, the agent's cost is still much higher than the humans. Yeah. But I don't know what we'll do in the future because most of the as you said, the token provider, as we know, we have some big tech company also have the Fireworks Altogether AI, this token seller, and they are trying to make the costs lower and lower, just like the DeepSeek. The DeepSeek's cost is much lower than the GPT's cost, and they are still get lower. It's hard to say at some points the costs are cheaper enough that can when it gets cheaper enough and the model gets more powerful, and then the cost of the agents are lower than the cost of a human worker. And also talk about the Boxuan, can I share the screen? I want to share a little bit.
Sure.
Okay. And for the browsing infrastructure, as I mentioned, I just sent a link in our chat message. This is another open source work. It's called Browser.io and very popular. It's got over 62,000 stars in the GitHub. And I just talked with their founders, and they are working on some browsing infrastructure things. And also for the previous question about the accessibility, in their demo, you can say when the code running, you can check the browsing progress that agents are doing. For each step, you can say they just tap some button or input some text, and it can make you get better know what agents are doing right now. And also they are providing some browsing infrastructure. And I would say if you are a small company or you don't have enough people to build your infrastructure, this is not an advertisement. They of their code are open source, so you can deploy by your own, and you can just use this good open source project and facilitate your business things. But if you don't want to deploy it by yourself, you can just buy their service. But I don't know how much they cost, but this may be one of the solutions.
Which project is that?
This is called browser use.
Oh,
Okay.
browser use. Okay.
Yeah, browser use. Yeah.
AI Tinkers Zurich.
Yeah. They also have their startup company. Yeah.
Yeah, just to add on, we didn't have human evaluators conduct all the tasks, so I'm not confident to say whether human beings will be cheaper to finish those tasks. Clearly, we can see, I think to many people's surprise, it's not very costly overall, but they're not yet to be able to finish all the tasks in any category.
But 30% is pretty good.
Yeah. It's already higher than our expectation. And it's interesting that we started this project a year ago, and back then the completion ratio was way lower. And things are just crazy these days.
Well, that would be a great way to wrap up the session. Thank you so much to both of you for coming in and doing the demo. The demo was fire, and all of the work that you've done, really, really helpful. I invite everyone to join our next paper club. We'll be talking about memory in the context of agents, and I shared the link in the chat, or you can find it on paperclub.aitinkers.org, and we'll see you then. And thank you for the great work in the presentation, and thanks everyone for coming.
Thank you for the invitation. Yeah,
thank you for the invitation.
If you have any questions that are not answered, we're sorry, but feel free to contact us offline. Thank you.
For sure. Thanks, everyone.
Bye.
Thank you. Bye.
Thank you. Bye.